This is part 2 of the 8.5 notes. We're going to talk about area of a segment. So what we're doing is we're taking the area of this entire sector right here. So we're going to find that entire area. And we want just this piece right here. So we're going to find the area of the triangle and take that out of the area of the entire sector. So that's how we're going to do this. So this is always going to be an isosceles triangle because the radius of the circle doesn't change. So it's going to be something. Okay, so for our first example, we're going to find the area of this blue piece right here. Okay, so the first thing that I want to get the area of that segment is I want the area of the entire thing. So I have to find the area of the sector. So I have to go back to what the formula was. And remember, we're talking about the area of the entire circle times just the portion that we want. That's our percentage. So in this case, the radius is 16 and theta is 90 degrees. So the area of our sector is going to be pi times 16 squared times 90 over 360. So I'm going to do pi times 16 squared times 90 divided by 360. Now I'm not going to be able to put that into a fraction because I multiplied the pi in there, and I did that because this isn't going to be my final answer. I'm still going to need to do something with it. And then it didn't give us units. If I wanted to keep them separate, I could. So 16 squared times 90 divided by 360. Okay, and then the next thing I need to do is find the area of the triangle and essentially take it away from the area of that entire thing, and then what's left is just the blue piece right there. So the area of the triangle is 1/2 base times height. Now in my right triangle, I have both of those pieces. The base is 16 and the height is 16. So I'm going to say 1/2 base times height. So now I have 16 times 16, and either multiply by 1 divided by 2, or you can just divide by 2, or what I like to do is multiply by 0.5 because then I don't get lost in any of the fractions. So then to get my final piece, I'm going to subtract them, and that's going to give me that blue piece. And this is why I just multiply the pi in anyways. So you could have two answers here. You could say, depending on what your teacher wants, 64 pi minus 128, and then that would just be the answer, because you can't simplify that without rounding. What I'm looking for is take the 201.1 and subtract the 128. So 201.1 minus 128. So 73.1. And then I'm going to say units squared, because it didn't give us units. Okay, for our next example, we're going to do that same concept, except this time the area of the triangle isn't going to be as easy. So I can find the area of the sector. So I'm going to find the area of the whole thing. I'm going to use green for this one. So I'm finding this piece right here. I'm finding that whole thing. So area of the sector, and that's going to be pi r squared times the angle over 360. And in this case, that's r. And then I know that my angle is 140 degrees because it tells me. Okay. So then I'm going to type that in. So pi times 50 squared times 140 over 360. And it did give me units, centimeters. Okay, now we need to find the area of the triangle, and that's going to be a little more difficult because it's not a right triangle. So I'm going to actually redraw that right here. Okay, so I don't know the length of this base piece, and I don't know the length of the height. So what I'm going to do is view just this right triangle right here. So this was my 50, because this is my isosceles triangle. And there are a couple ways that you can kind of approach this. I know that this big angle right here is my 140. Well, this is cutting it in half, so that's 70. You can also find this one and this one. I'm not going to worry about those. So the first thing I want to do is find the height of this triangle. And then I'm going to go through and find, see what color haven't we really used. We'll just reuse this one. Just this base right here. So it's half of the whole thing. So I'm just going to find the area of half of my triangle, because then I'm looking at a right triangle. So that's what I'm finding the area of. Okay, so I can use trig functions to find the height, because if that's 70, this is the opposite side, the adjacent side, and the hypotenuse. So cosine is adjacent over hypotenuse. So cosine of 70 is going to equal the height divided by 50. Multiply that over. And I get 50 times cosine of 70. Then I'm going to do a similar setup for the base. So on this one, that's opposite and hypotenuse, so that's sine. So then I get that the base is 50 times sine of 70. Okay, so that's how we're going to find the area of the triangle. Because we're going to use that information. Now keep in mind that this is only half of it. So I'm going to multiply by 2. See if you can see that a little bit better. We're going to multiply by 2 because there's 2 of them. And then it's 1/2 base times height. Well, we said that the base was 50 sine of 70. Didn't leave myself enough room. And then the height was 50 cosine of 70. That's going to give me the area of the triangle. So my area of that right triangle right here is the 1/2 base times height, and then I have to multiply it by 2 because I have 2 triangles. So we're going to type that in. Well, the 2 times 1/2 is just going to reduce to 1, but feel free to still type that in. And then I'm going to do times 50 times sine of 70, close the parenthesis, times 50 cosine of 70, close the parenthesis, and we get 803.48. So round. Okay, so if that is the area of the triangle, then I can find the area of the entire sector right here, or the area of the segment, by taking the area of the sector and subtracting out this triangle right here. So I'm going to take area of the segment is equal to 3054.3, so 3054 and 3/10, and I'm subtracting, I didn't use a fancy color for it, 803.5. Okay, so that's what we're going to do. Let's take that 30, 54, and 3/10. There we go. Minus 803.5. Okay, so that is the area. It's at 2,250 and 8/10, and the units were centimeters. Okay, if you do not know how to use trig ratios yet, go ahead and ask your teacher how they want you to find the area of the triangle. And have a good day.